What is covalent bonding? We're going to be looking at covalent bonding, what it is and how it happens. So covalent bonding occurs between non-metals. As regards to looking at ionic bonding, which occurs between metals and non-metals, covalent bonding occurs between non-metals. One of the key things to remember. The other difference between covalent bonding and ionic bonding is that in covalent bonding the electrons are shared, which means unlike ionic bonding there is no electron donation that occurs between atoms. This is an example of covalent bonding. Hydrogen is the first atom in the periodic table. It has one electron in its outer shell. Now hydrogen wants to have two electrons in its outer shell. It has a space here. So it can't collect electrons from other atoms during covalent bonding. What it does instead is it shares electrons. So this is an example of a hydrogen molecule. So hydrogen can always be found as H2. In other words, there are two atoms of hydrogen. What happens is another hydrogen atom covalently bonds to that hydrogen, and we can represent that with something called a dot and cross diagram. Now one of the rules of a dot and cross diagram is that one of the pairs has to be shown as a cross and the other atom needs to be shown as a dot. This way it's easy to see where the covalent bonding is occurred. Now we'll have a look at the example of a double covalent bond. A double covalent bond occurs when a non-metal, we're going to say carbon, shares its electrons with other non-metals such as oxygen. Now in carbon dioxide the chemical formula is CO2, so from this we can see that there are two oxygen atoms which is added to or covalently bonded to the carbon. So we're going to represent that covalent bond. So carbon and two oxygens covalently bonded to the carbon. So I'm going to represent the carbon as crosses. And as you can see, carbon has 4 electrons in its outer shell. Now I'm going to represent the oxygens as dots so you can tell the difference. And oxygen has 6 electrons in its outer shell. So 1, 2, 3, 4. And what I'm going to do here is I'm actually going to put these electrons in this area because I know that I'm not going to add anything to this area. 5 and 6. And again here, 1, 2, 3, 4, 5 and 6. Now if we have a look here you can see that carbon now has 1, 2, 3, 4, 5, 6, 7, 8. So it has a full electron shell. And oxygen now has 1, 2, 3, 4, 5, 6, 7, 8. And this one also has 1, 2, 3, 4, 5, 6, 7, 8. All electron shells are full for each of the atoms. And this is carbon dioxide. Now if you wanted to represent this as a stick model, so a structural formulae, it would look like this. Carbon, double bond, which is the double covalent bond attached to the oxygen, with a double covalent bond attached to the oxygen. So this here represents a double covalent bond.